Hey guys, I wanted to come back here today and give you an example of how to balance a half reaction of a redox reaction. Okay, so what I've got up here is just H2S going to SO4 2 minus, right? This is hydrogen sulfide going to sulfate ions. This is a half reaction. We'll find out that this reaction has some electrons moving around, which means that something else would have had to have gained those electrons or lost those electrons. Okay, so what we're going to do to start to figure that out is we're going to first off assign oxidation states. Okay, so first off, we look at hydrogen. We know that hydrogen oxidation state is normally +1 unless it's bound to a metal or if it's bound to itself. So we're going to assign it a +1 up here. Sulfur then, right, if we say hydrogen is +1, we've got two +1s. Overall, the molecule doesn't have a charge, so that means that sulfur has to be a -2 here. Okay, let's mark this maybe a little bit darker so we can see it. Okay, so now let's come over onto the right-hand side. We know that overall the molecule has a 2- charge, and we see that oxygen here is attached. Oxygen normally is going to be a -2 charge. So we're going to give it a -2 charge there. -2, we have 4 of them, so that means that oxygen in this would be -8. But our molecule overall is a 2- charge. So my sulfur then, to get from -8 up to -2, sulfur has to be a +6. Okay? So I'm going to erase here now hydrogen, because we don't care too much about hydrogen. It's not going to be changing, and I don't care too much about oxygen, because it's not changing. I see that sulfur is changing oxidation states. If sulfur is changing oxidation states, this is a redox reaction, right? So I need to go through my steps here. Okay, so first off, what I need to do is I need to balance the element that changes its oxidation state. So fortunately, in this reaction, I have one sulfur on the left-hand side, one sulfur on the right-hand side. I don't actually need to do that step. So I'm going to skip then over to step number 3. I need to add electrons to account for the redox reaction. So in this reaction, what we see, right, we have H2S. We start from a -2 charge for sulfur, going to sulfate ions. Sulfur is now is a +6 over there. That means that 8 electrons were lost. I started at a -2. If I lose 8 electrons, it's going to become +6. Okay, so do that math and you'll see that that actually does work out, right? So now I have added the electrons to account for my redox reaction. Now I get to go down here to step number 4 and I balance my oxygens using water. Okay, the reason why I use water is because most of our reactions are going to happen in water, and water itself actually follows those redox rules that we had before, right? Water overall doesn't have a charge. Hydrogen we normally say is a +1. So a +1 times 2 is a +2. Oxygen is a -2. So overall, my molecule is uncharged. Okay, so I'm going to use water to balance my oxygens. I have 4 oxygens over here on the right-hand side, so I need to add 4 oxygens on the left-hand side. What do I add? I add 4 H2O molecules. Okay, so now I have 4 oxygens on the left, 4 oxygens on the right. Those are balanced. Now I get to go down here to step 5. I get to balance my hydrogens using H+. Again, the reason is because when we balanced it using water, hydrogen was a +1. I need to keep that +1 down here on the other side. So when I use H plus on the right-hand side, I see I have 4 times 2, that's 8 hydrogens, plus these 2. That means that I'm going to have 10 H plus ions over on the right-hand side. Now the last step is really just to check ourselves. Again, just like when we were balancing our chemical reactions, we can always check ourselves at the end here. The way that we can check is we can make sure that everything is balanced. So first off, my sulfurs are balanced. I have 1 sulfur on this side, 1 sulfur on the right side. My hydrogens are balanced. I have 8 plus 2, that's 10. I have 10 hydrogens over on the right-hand side. I have 4 oxygens. My charges balance because I have a -2 here, a +6 there. That's 8 electrons difference. That has 8 electrons over here. The last thing that I can check is also just my overall charges. So if I look over on this left-hand side, H2O doesn't have a charge. H2S doesn't have a charge. So my left-hand side does not have any charges. So that means that my overall on my right-hand side, I can't have any charge either. So let's see if that is correct. I have a 2- charge for my sulfate ion. So that's 2-. I have 8 electrons. That's 8 times -1. So that's -2 plus 8, or plus -8. That's a -10. I have 10 H pluses. So 10 H pluses, that's 10 positive charges. I have 10 negative charges. Overall, my right-hand side doesn't have any charge. We always get to check. Keep that in mind. We can always check to make sure that our reaction is balanced.